All right, so you've asked for a Zig Postgres tutorial, and I guess I'm kind of here to deliver. So let's talk a little bit about it. So what I've got on my screen is a couple different things. So the first thing I want to point out is the Postgres library that we're going to use. It's called pg.zig. It's a native Postgres driver and client for Zig. Always happy to see native solutions. And then we're going to use Zap. So Zap is what you all have requested. It was fun exploring this. So this is blazingly fast backends in Zig. It's C, actually, under the hood. So it's the C networking library facil.io, not sure how to pronounce that. Probably facil. But it's essentially just Zig bindings for facil, and maybe a couple extra things thrown on top. It's really fast. It is extremely fast. I'll give it that. But I've ran into a bunch of issues, and I want to make sure that we talk about those as we go. So the code itself is actually not too complicated, but while we're doing that, I'm going to go ahead and just boot up Docker. I'm going to boot up a Postgres instance here. So Docker run E, wow, that was quick. E, Postgres user, Zap user. So that'll be the user that we're connecting to, Postgres DB, Zap DB, Postgres password, ABC123. Nice secure password. And then we need to set the port so we have access to it. And then that's the container image. This is running, looks good. Database created, excellent, excellent. So the next thing we can do is build and run our application. You'll notice that there are memory leaks detected by the GPA. I'll talk about those in a minute. Actually, it'll probably be closer to the end of the video, but we'll still talk about those. Okay, so the server is running, listening on port 3000. There's a open file limit. I'm running one worker with one thread. It's so fast. You could potentially, up the numbers. You just got to be careful with mutable state if you're using multiple workers or threads. So for simplicity's sake, I was running 1 and 1. Actually, I was running 2 and 2 originally, and then I started debugging some issues, and I swapped to 1 and 1 to simplify things, and I never swapped back. So that's how fast it is. I forgot that I wasn't running multiple threads. But yeah, so this is booted. It's up and running. Let's go ahead and hit localhost 3000. You can see not found. Pretty good. You can see that we're handling the not found blazingly fast. But it's just a not found status. Like, it's really not that complex, right? Or actually, technically, it's not even a not found status. I have an incorrect status. I have not found, but I'm giving you a 200. So something to fix for sure. Okay, so we have something up and running. So let's talk about the server and what it can do. So let's just prove that it works first. I've got some tests over here. So I'm going to go ahead and get all the users. You can see that we get an empty object. It's pretty good. We can add a user. I'm going to add a user named Brad. And then if I get all users, you can see that there's a user named Brad. Let's add another one named Jacob. And Jake, if you're watching this video, that's for you. And you can see there are more users. So we're storing users. We can get specific users. So I can get Jacob. And then I can also delete Jacob. And now if I try to get users, not found, because we don't have a user number 2 anymore, and we can prove that by getting all of the users. So our data structures aren't complex. What we're doing is not complex, but this is the foundation to work with Postgres and Zig and Zap. So let's get started. I'm not going to code this out for you. Sometimes I will just live code these things, or just code things out, maybe not live. There's no benefit to me typing everything out line by line. And in fact, I think it will probably be more beneficial for me to go over the existing lines one at a time and talk through them. So we're importing standard library, nothing crazy going on there. We're importing Zap. You got to import Zap to use it. Same with Postgres. We're importing Postgres. Got to import them to use them. That being said, in our build.zig, we have to add those dependencies. So you can see here's how I'm adding Zap. And I'm going to close out this response tab just so you have a full screen to look at. So you can see that we're adding Zap here. Let me make this slightly bigger. So we're adding Zap, and then we're adding Postgres. Very straightforward. We have to reference those in our build.zig.zon, since these are external dependencies. I should talk about this. So here's Zap. You can find install instructions on Zap's GitHub page. Same with the Postgres. Worth mentioning, one thing worth mentioning, I specifically grabbed a 013 Zig branch for this Postgres version. The master build or the master branch is not necessarily tested for 013. I think it's tested for like a more nightly build. So just something to be aware of. These hashes, you don't write these yourself. Just use the Zig command. Zig. I never remember what that command is, so I'll tell you a secret. I wrote a blog post that I can just refer to, so I don't forget. Yeah, Zig fetch. There you go. Something like this. It'll generate the hash for you, so you don't have to actually try to figure out what the heck that is. So Zinc, let's talk about this. I had so much of a struggle with Zap at first that I looked at other alternatives, and I found this library called Zinc, and I actually like Zinc better. It's not as fast, I don't believe. The API interface for Zinc is more like Go's HTTP layer, so focusing with like contexts and things of that nature. It's in early development, so it's not all there yet. I can remove this. I don't need to use this. I don't use this anywhere, so I can go ahead and remove it. But the point being, I looked at Zinc as well, and I really think you should look at it and follow along, because my hunch is that it will be a nicer project to work with than Zap, and we'll get into that in just a minute. Okay, so I broke out a controller into a separate file called users controller. We import that. We'll take a look at users controller when it becomes relevant. In the simplest sense, we have a not found here. This is that page that we are showing in the browser. So this page right here. So I have request.sendBody not found. I could do request.setStatus not found, which maybe I should. And then if we run this again, go ahead and let this run. And now if I actually make this request to this page, you can see that the status is 404 and not 200. So small fix. Glad we looked at that together. Anyways, that's our not found handler. We'll use that down here in just a minute. We have our main method. I'm getting a GPA. I'm setting it to make sure that it's thread safe. I'm getting access to the allocator. And then I'm creating a pool of connections in Postgres. So a connection pool. This takes in an allocator. And I think this is part of my memory leaks that I'm running into. So I'm a little uncertain exactly where they're coming from, but a lot of the signs are pointing to the Postgres library that I'm using. And I'm checking the documentation to make sure that I'm not forgetting to free anything, and I don't think I am. So yeah, I think that there might be some leaks in the library. I also could totally be wrong, and if you're the library author, I am sorry. I'm not trying to slander you. There's a very good chance that the leaks are my fault, and they are just surfacing references to the Postgres library. That being said, just something to be aware of. I'm running into leaks around that area. I still have to fix those, but I didn't want to delay the video on me fixing those. So we set up some connections. Here's our host. Here's our port. Zap user, zapdb, abc123. We mentioned that all over here in our Docker command to run Postgres. So that's where those values come from. The very first thing I do is I execute a statement against the pool. So this pool is interesting. You can execute directly against the pool, in which case it is supposed to, and I think it does, but I'm not positive. It will establish a connection or grab a connection from the pool, execute the thing that you want to execute, and then release the connection. And it's supposed to free up memory, but I'm not 100% sure it's doing that. Again, could be wrong. But I am just simply running a really basic statement here. Create table if not exist users, and then there's the structure for the table. This is essentially, you probably would want to like spin up a Postgres instance and run migrations and create your tables, but in my case, for this simple project, I'm just creating the table if it doesn't exist. Yeah, so let's get into the Zap bit. So we have a router. So this router is responsible for routing your request. That totally makes sense. So we have to initialize it. We give an allocator, and we can give it some options. The only one I'm providing is the not found route right now. So this is the handler for if something is not found in the router. We need to defer deinitializing that because we clean up after ourselves, or we try to at least. And then I've got this user controller. So I've got this user controller package, a user controller struct, and then I'm initializing it with an allocator and a pool. The contents of the user controller itself are a little weird. So we'll get to that again. We're almost finished with the main method, so we'll jump to that in just a second. Next, we create a listener. This is a Zap endpoint listener, not a Zap HTTP listener. It's different. So this is specifically made for working with endpoints. So endpoints are kind of like controllers. in the sense that they are things that are generally structured together and they take in an endpoint and a request, and you can do things based off of that. And you'll see it in just a minute. We specify the port we want to run on, 3000 in our case, and then we have this on request. And this on request is really nice because what we're pointing it to here, what we're using for the on request, my English is struggling today, is the on request handler from the router. So if you were to establish routes and you wanted to add things to the router outside of endpoints, you would add them to the router here, and then this on request handler would trigger that type of stuff for you. We're deferring deinitializing the listener because we like to try to clean up after ourselves. And then we're registering the user controller endpoint. So the user controller furnishes a Zap endpoint at this endpoint method, and we'll look at that in just a minute. And we're essentially registering that into the listener. I'm not handling errors very well because this is a fun little toy project, so I'm just trying a lot of things. But if you were to do this, you might want to catch errors and actually handle them appropriately. Then again, this is our server booting up, so maybe you do just want to fail if you can't register your listeners. Finally, we say listener listen. So we start listening, and after this, no more endpoints can be registered. I just mentioned that we are running on 3000, so I print that. And then we call start. And here you can specify your workers and threads. Worth mentioning, if you are doing things with like mutable memory and state, so like one of the examples for endpoints that they have in the Zap documentation is they have just like a hash map that is holding users. And if you are doing that, you can only have a single worker because you are accessing shared mutable state. So just something to be aware of. If you run into issues around that, just maybe check what you're doing and then check your threads and your workers and make sure it makes sense for what you're doing. Okay, with that in mind, we really only have one file left. Things are moving right along, and the file is the biggest one. So it is the user controller, and it's still really, it's not that big. It's 145 lines of code, so not too bad at all. So here's what I've got going. I'm importing the 3 imports from the main. So we're importing standard, Zap, and Postgres. And I create a couple structs. I've got a struct to represent a user. This is a user from our database. I've got a new user request struct. So this struct models this data right here. And then I have my user controller. So this is the big struct. This is where all the magic happens. It has access to the pool, the allocator, and the Zap endpoint. The endpoint's undefined by default. And what I do is when we initialize it, we create the endpoint. So you can see that basically what I'm doing here is really straightforward. For the first 2 lines, I'm just assigning the pool equal to the pool that gets passed in, the allocator equal to the allocator that gets passed in. And then the endpoint, I'm creating a new Zap endpoint using Zap endpoint init, setting the path to /users. And then the get, post, and delete are being set to these methods. You'll notice there's a pattern that makes sense. Post is save user, delete is delete user. One thing I couldn't figure out was if there was a way to specify different handlers for get and get all. So whenever I get a request, get a get request, receive a get request, I call dispatch, and dispatch looks at the request and says, oh, this is get all, or oh, this is get a single item. And then it delegates to the appropriate one below. And we'll see that here in just a minute. A key thing worth mentioning. So I had originally tried to approach this without using Zap endpoints, and I was just manually wiring things up on the router. So the struct that I created, originally all of these methods like dispatch, get users, they weren't taking an endpoint and they were taking a reference to self. I still need access to the pool and arguably the allocator. So I need a way to access that, and we'll get to that in a minute, but the short and sweet is that it's a bit of a strange pattern. It makes sense. There are pieces of the language that support this, but the pattern for accessing it was a little strange. So just keep in mind that if you're using endpoints, you'll have a bit of a strange pattern, and we'll see it here in just a minute. I have that endpoint method that just returns the endpoint, or reference to the endpoint, I should say. That's used in the main method. We pointed that out. We can take a look at it right quick. So it's right here, listener, register, end user controller, endpoint. Okay, back in the user controller, here's that dispatch method. This is probably the cleanest of all the handlers you're going to see because it just essentially delegates to other handlers. So we check if there's a path on the request because there might not be. And then if we are able to get a user ID from the path, then we call get user. And if we are not able to get a user ID, we call get users. So we check to see if there's a single user ID in the path, and if so, we call get user. If there's not, we assume we're getting all the users. You might be able to fudge this in a way where something that might want to be get users might want to be get user actually ends up being get users. There's some responsibility or onus on the developer to make sure that that works like you would expect. Yeah, so I think we're good there. Oh, I'm sorry, I missed one thing. If we don't have a path, we set the status to not found. I actually don't think that we need this. This is kind of interesting. In fact, this probably just belongs up here. My hunch is that if we get into this path, it is erroring out on this and catching it and just returning, so it's very safely failing. Oh, in theory, this should just be up here. And the reason why is that the request is being written by get user or get users. Okay. Fun thing worth mentioning, and this is where I started to run into my biggest issue with Zap, and it just wasn't obvious at all, to the point that I ended up filing an issue because I was uncertain if something was wrong or if I was just doing something wrong. Spoiler alert, I was doing something wrong. Originally, I had this returning, the return type was an error or void, an error union with void. So the issue here was not apparent at all. What I was finding is if I tried to access request, it would seg fault. And I was very confused as to why accessing a request would trigger a seg fault. My understanding here is that because of the way that we're bridging the requests through the C library, we lose a little bit of that safety that we would get if the whole thing was written in Zig. Or maybe the types around the C interface might need to be a little tighter. I don't entirely know. But what it boiled down to was this is not the return type that is required for a handler. This is the required return type. If we had full type safety, I would expect that the Zig compiler would say, hey, you're doing something wrong here. So somewhere, somehow, I think we're losing a little bit of type safety. And my hunch is that it's because we're, delegating to the C library facil.io under the hood. Okay. So this user from path, this isn't anything special. We just look at the path as a string. We do some slicing and dicing to figure out if there is an integer that we can pull from the path, from the end of the path. Get users, where we use that is up above, just in case you forgot. Get user ID from path. And then also I think we use it in get user. So get users is probably one of the more complicated ones. This is the part that feels really weird to me, and it's a thing. This is not some magical method that I made up. This is something provided by Zig. It just feels really weird to me. But again, maybe this is more of the systems programming type stuff that I haven't done, and maybe this is more common. But we're able to take a pointer to a field, so in our case, the Zap endpoint, and then I'm able to say, this is the name of the field. Now give me the parent struct, which just seems so strange to me, but it seems powerful too. And the short and sweet is that I do need access to the self, the self being the user controller. And I didn't have a way to do that because the method signature for these endpoint handlers require it to be this, and I can't take in a self. At least I was not able to figure out how to make that happen. It's worth mentioning too, I think I'm a pretty good developer. Every now and again, I will run into a project that humbles me. This has definitely been a humbling project with my knowledge of Zig and where I'm at in my learning journey for Zig. It has been quite wild. Tons of new learning opportunities and tons of things that I've ran into and jagged edges I've metaphorically cut myself on. Anyways, again, we're checking if we have a path, and then if so, we are querying. So I'm doing a select ID name from users. We want to get them all. You probably would want to paginate this and handle, pagination and offsets and things like that. If you are following along, everything you've seen so far gives you the tools to do that. So I believe in you. And in fact, you'll see more of it down below. I guess we technically haven't gotten to parsing JSON, but whatever. So we get that result. and then we defer deinitializing it. I'm using an array list here, and then I'm just iterating through the iterator that we get from querying, and I'm getting the ID. So I know that the 0th column is ID, the first column is name. So I specify the 0th column is an I32 because it's an ID, and then this is interesting. Row.get is a slice of U8. It's a string. Column 1, oddly enough, the LSP for some reason at this point in time believes it's an I32, even though down here it's aware that it's not an I32, which is kind of strange, but it's fine. So we append those users, and then I create a string because we need to parse this to JSON. I get that user array list. I convert it to a slice. I defer freeing the slice, and then use JSON stringify from the standard library to stringify it into a string. Finally, I get that string, and yeah, the LSP types are all messed up right here. I get that string and convert it to an own slice. I defer freeing it, and then we send that back as the body. Does that make, well, I'm asking if that makes sense. This is recording and not a stream, so no one can respond, but hopefully that makes sense. Save user is a little less complicated, but you'll notice some similar patterns, and for that reason, we'll move a little faster through some of these. So I'm getting access to the user controller through the field parent pointer, like I mentioned before. We're checking this time to see if there's a body. If there is a body, we are unwrapping it to body. And then what we're doing here is we're trying to parse that. So I am using standard JSON parsed new user request, and then specifically calling parse from slice from standard JSON. You have to pass it a type, so I'm passing in the type of new user request. You give it an allocator so it can perform allocations, and then you give it a body that you want to, parse. So I'm parsing there. You can also provide options. I haven't looked at these too much. I just left it blank and continued on, and it worked fine. So there may be options that may be useful for your use case. Check them out. I'm catching an error, mainly because instead of just trying this and seeing what happens, I can't try it because I can't elevate the error up. But also, I ran into a bunch of issues with parsing at first, and the issues were really straightforward. I had a comma right here, and that's not valid JSON. So yeah, it was a little confusing as to what the issue was. I was seeing that, I think the error was JSON syntax invalid, which really was not very helpful. But I was able to identify that, and it made me really think through this error path, which is identifying that this is a bad request. Once we've done that, we maybe have a user if we were able to successfully parse it. So we unwrap the user. We defer deinitializing it, and then I'm executing against the pool, insert into users, name, values, and then I use the user's name as the value. We catch, and if we catch anything, we have an internal server error, or we inform the request that we've had an internal server error, and then we return. Get user is going to be kind of an amalgamation of everything you've seen so far. Again, getting access to the self via the field parent pointer, checking to make sure we have a path. If we do have a path, we get the user ID from the path. If we do have a user ID, then we use a different method here, self pool row instead of self pool exec or self pool query, which were the ones we were using up above. So here's query and get users. Here's exec in save user. So this returns a single row. And if it returns more than one item from the query, it will have an error that it returns instead. So we check to see if there is a result. And if there is a result, we unwrap it. And if so, then we parse that into a user, similar to what you saw earlier. And then we have another string that we're creating because we're going to stringify. So this is very similar to what you saw earlier. Same with owning the slice, deferring, freeing the slice, and then sending the body. The main thing here is that we have a couple of, not exception paths, but the other ends of our if conditionals here. So in this case, we indicate that we were not able to find the user. And then also if we can't get a user from the path, we also say, hey, we were unable to find a user. There's also this example that is like, if a request path is not filled, we probably should handle that case as well. Maybe another bad request. Finally, we have delete user. So we have a Zap endpoint here, another request. Same thing as before. Actually, at this point, you probably should understand everything that's going on, but I'll walk through it one more time anyway. So we're getting access to our self from field parent pointer. We're checking to see if there is a path. If there is a path, we're getting the user ID from the path. We know that that user ID that we get back is a usize, I guess, which I thought was, no, it is usize. Okay, cool. And then we use self pool exec to delete from users where ID is equal to the ID that was passed in. We catch an error. If there is an error, we tell the request we had an internal server error and then return. Otherwise, we say everything's A-OK. And that's it. That is a server that's working. So if you wanted to add puts, you could add puts. I mean, hopefully everything you see here is enough to help you get started. But, you know, if you wanted to add a put, you'd add a put here. Blah, blah, blah. If you wanted to add a options, you do options here, that type of thing. And you can build out more controllers, kind of following this pattern. If you don't want to do controllers, you can essentially just use the router directly and register routes on the router. You have so much flexibility. So hopefully this has been helpful. I know that I've had so many people request something around Zap and Postgres. My takeaway from this is that I probably won't be doing more with Zap for a while. I know that we have Zig 014 coming out soon, and I'm really excited to see that. But also, I don't know. It's tricky. It's so fast, and it feels good. Like there are a couple things that feel off to me. Specifically, this field parent pointer bit feels off, and maybe there's a better way to approach this. And if there is, I would love to see it. Honestly, though, I guess besides that, it's not too bad. The big rub for me was I spent I work on these tutorials and content and personal projects part-time. So I spent part-time 3 days trying to figure out why I was having a seg fault. And it wasn't clear to me. So the error messaging around that was problematic. Expecting tighter type safety from a very type safe language like Zig, problematic. I expected that and it just wasn't delivered. So it's tricky for me because those type of things are really important. But on the flip side, wait, did I add this? Why is that? Oh, that's fine. Sorry. That one's fine to return an error because we're catching it in the dispatch. That makes sense. I don't know. My thoughts are a little mixed. Now I know that these are issues and I won't run into them again. So maybe I'll have a better time if I were to build another thing from scratch. And it may be significantly quicker at this point. But yeah, it also may not be. And again, I mentioned Zinc. Let's pull up Zinc really quick. GitHub. Oh, shoot. Zig Zinc. I was like, how do I get to that? Yeah, so it's a framework written in pure Zig with a focus on high performance, usability, security, and extensibility. Not the fastest Zig framework in the universe, but fast enough. That's fine with me. I'm happy to make a speed trade-off for speed of development, especially if it's not a huge trade-off, like I'm not writing in Python or something, for example. This looks clean. I love this. I really like this. Given that you're just taking in a context too, there are probably really nice ways to structure things into controllers if you like that idea. Or not if you don't like that idea. So I'm really hopeful for this library, Zinc, and I'm hoping to see more from it. It's just more my speed. That being said, Zap still seems really good. Just be careful with the rough edges. They've been rough for me, and hopefully you are more intelligent than I am, and I'd like to think that you are. And you won't run into them, or if you run into these issues, you'll very quickly see what the issues are. And be able to resolve them. Anyways, hopefully this was helpful. I will push up this code so you can reference it should you like to. And then I will put a link in the comments below and you guys can comments, description, I'm not sure, maybe both. But you can take the code, run with it, and do whatever you want. Totally forgot memory leaks. Yeah, so I mentioned these a little bit. So one thing that is worth mentioning, this code is allegedly very full of memory leaks. So I'm trying to track them down, and it looks like initialization of the pool has some issues. It points to, you know, some lines in the pool where we create a new connection, and then we open the connection, and then we try to use a reader here, and then we try to allocate space for static contents. This, if I keep scrolling, you'll see this all over the place. So I don't know exactly what's going on. There are some memory leaks in the code that I am sharing, so just be aware of that. As to tracking them down, that may be something I do. That may be something I'm unable to find the time to do. So your mileage may vary, and you know, all software is distributed as is. So have fun with that if you want to solve those. And if you are able to solve them, and maybe submit a PR to help other people out who might find this project and also want to run with that code. Thanks for sticking with me through this video. I know it was a long one. I hope this has been helpful and hope it meets the needs of the people who wanted the Zap Postgres example. So thanks. And if you haven't yet, subscribe to the channel. More Zig stuff coming soon, especially now that macros are killed off in the Dart language. Kind of still devastated about that. But maybe that means I'll just write more Zig. All right. Thanks. Have a great day.